aren't you? Come early, stay with them. You get the pre-show. So the music you're hearing, if you're watching, if anyone's in the back and wants to come closer, I won't set you on fire, I promise. But do come closer, and then I can like heckle you, and we can talk more about all this automation stuff. So, quick side story. So, do you want to hear the story? Settle down, talking to you. Hey, Danny. What?
We can't hear you over the music.
Oh, that's good. It's over. What? That's fair. When do I start?
You can start right now, because everybody who wants to be here is here.
Yeah. So, I'll start in a moment. I guess it's a little cut off at the bottom, but just random, if you want to hear this weird random story, it helps me warm up my speaking voice. So the music you just heard actually, can you hear me in the back? Yeah? Okay, good. I'm not so pro with the microphones. Yeah, so the music you just heard actually, so my grandmother used to play this piano music for me, and like no one's heard of it. She was really old, she's dead, but it's this random obscure piano music that she had, and she would play it for me all the time. And when she died, I kept a copy of this music. And I looked it up online to see if I could find it anywhere, and no one has heard of it at all. So what I actually did is I actually scanned a copy, and I posted about it on Wikipedia. Like I added a little short entry. And basically, 6 months later, I started to find hits on eBay and stuff for this music. And what I think happens is people's grandmothers die, and they take all the piano music, and they find if there are existing references to it online, and if so, they sell it. So meanwhile, no one's heard of this song except, there's a Wikipedia entry. And so I've started buying up all the copies of this one piece of music. And so now I'm actually the world's largest collector of this one random obscure piece of piano music. And if you're interested, it's there's Imager, like scans online that I put. It's called Dorothy by Seymour Smith. And it tests the audio. So that's the story. They're like, who is this weird guy and what am I doing here? This is not piano music class. All right. So. Does anyone mind if I sit? Can you hear me if I talk like this? It's still okay? No? Oh, sorry. All right. How's that? I'm going to sit because I'm going to be typing a lot. So if you really can't hear me, just like put 2 hands on your head or something, and I'll try and look up and notice. All right? Cool. So I guess I'll get started. So my name is James. I go by Purple ID on the internet. I work for Red Hat, but this is just a project. This is not a product that I'm talking about. This is basically I work on research and prototyping things, and I'm very passionate about the config management field. So just to introduce myself, so who am I? I'm a hacker. As I mentioned, I work on config management stuff. I actually write a technical blog. Who's read my technical blog before? Awesome. Is it your favorite blog on the internet? Just say yes. All right. Did anyone see the blog post I posted about this software? Yeah? A few. All right. So I'll try and keep up. I'm going to go pretty fast. But if you're lost or you're really, really lost, just raise your hand and I'll try and get to it. I'm actually a physiologist by training. So if you want to talk about cardiology or something, I really don't use this anymore. So I'm really happy to nerd out. And I'm actually a DevOps believer, and we're going to get to that. So if those of you that know me and know my sort of tainted history, you might remember some of my Puppet hacks. Does this look familiar? Yeah, that's Beaker. I actually used this guy in a slide I gave in PuppetConf. I think it was Lisa 2013 or something. But if you follow my blog, I've come up in the Puppet community, and I write all sorts of scary things in Puppet like, oh, I'm totally sorry. So this is my, seriously, give a round of applause to Chris, because I really wouldn't be here without Chris. Chris really helped me get my talk accepted, and it was really great. Otherwise, you'd be getting like, not a talk from me. So yeah, anyways, right. So background, a little background. So I started hacking with Puppet, back in the day. I think I got pretty good at it, and I built some pretty outrageous hacks, which I'm going to just really, really quickly remind you of. And this was the talk I was talking about. So you might have remembered something like this. I wrote like recursion in Puppet, because when I was playing with Puppet, I found that you could actually do this. I haven't tested this with Puppet 4 or anything like that, but this does actually work, at least in a earlier 3 series, probably later. You can look at this online. I actually have this thing that I wrote in Puppet that basically Puppet decides when it wants to run this thing again, and this is exec will basically double fork a Python process, watches and waits till Puppet ends, and then either with a timeout or right away relaunches Puppet right away, so you can have it run multiple times. In general, on a single machine, this is a terrible idea, but for multi-machine things, when you need to converge, you like mathematically have to run more than once with Puppet. So this is sort of a little hack. All this code's out there. I built timers because I wanted to build some pretty advanced things. These are kind of dirty Puppet hacks. So I'm really sorry for all of the people that had to see these, but they did teach me quite a lot about Puppet, and I wouldn't have learned everything that I did without Puppet. I actually built a finite state machine. This is all on my blog if you want to look at this stuff. Kind of a weird thing, but I'm not going to talk about these things today. The question is this really the right way to do everything? All these dirty Puppet hacks? You guys are asleep. You want me to throw more fire at you? Is this the right way to do it?
Yes.
No, it's not. I don't think it's the right way to do it. So this is my guy. Have you seen this guy? He's my nope guy. And he just nopes out right there. And the nope cannon, and you know, goodbye nope guy. So I want to talk to you. So basically, I finally sat down and I had these ideas of what I would really like a next generation tool to look like. And I've written a prototype. It works. I'm going to demo it shortly. But I want to tell you a little about the design principles. So there's three main design principles. It is completely running in parallel. So if you imagine a graph of your config management system, it has entirely parallel execution, which I'll show you in a minute. It's completely event-driven. So in contrast with an existing system which starts up, runs all the way through, waits 30 minutes, and runs again, this actually, on a file type, for example, will start up, check the state of the file, set it if need be, and have an iNotify handler that's there and waiting for something to happen. So you never, ever need to rerun unless the iNotify said, hey, I think something might have happened, in which case then you check, and only when you need to do work do you actually do it. All right? Everyone catch that? Okay, if I speak too fast or something, just let me know. And lastly, the whole system actually works as a distributed topology. So there's some server-client architectures that exist that you're all very common with. There's also some orchestrator technologies that have one thing that goes out and pushes at a bunch of, you know, clients or children or whatever you want to call them. I actually want a real, true distributed topology with no single point of failure and something that you can scale out in a very intelligent way. So I'll show you how I did that. So these are the three things. So this is just a graph. You can just think of these as different resources. This is basically the status quo. Can you see the red arrow? Okay? Yeah? All right, good. So basically, this is just a big graph. There happens to be two disconnected pieces, but this might be like what some of your Puppet code or Chef code looks like. And if you think about it, what these tools actually do is they do something called a topological sort, and that's basically this arrow. They just decide, well, if I go through 1, 2, 3, 4, 5, 6, or 7, then I'll get everything done in the right order, with the right ordering relationship. It could have done 1, 2, 3, 4, 6, 5, 7, or it could have done this left-hand part first and then the right-hand part, but there's some arbitrary topological sort, which it does, and that's how your graph normally executes in series. This is what my tool does, actually. It actually will take the right-hand part and run this whole block in parallel with the left-hand side. So they're really completely independent, and if there's no dependency relationships between them, why not run them in parallel? I don't know why this wasn't done before. I don't know why this wasn't done before. In addition to that, if you just look at this left-hand part by itself, once this first element here at the top is run, either of these two can both run. So we actually run these two both in parallel, and then once they've both completed successfully, then we can run this third one. Okay? So you actually split up the disconnected parts and run those in parallel, and as well as the individual pieces whenever the dependencies have been met. Any questions so far? Yes, one question. Felix.
So in the example of same packages, you typically cannot install packages.
Good question. We'll talk about it later.
Okay.
Yeah. Felix is asking an excellent question, and I don't want to get too deep right away. So yes, if it's just a simple question, ask. Otherwise, we'll leave the complex stuff for later.
Are you limiting yourself to Puppet, or are you talking about Terraform also, which can do these things in parallel?
So actually, I wasn't talking about Terraform, but we'll talk about that later if you want. So that's true. So here's the actual example that I'm going to show you. So there's basically 4 exec types or resources if you want. These first 3 have a dependency, and this fourth one is a dependency chain on the left, and this fourth one is just basically sitting by itself. And I'm just going to, oops. that's a little loud. Oh, here we go. Got a little terminal. So my tool actually uses etcd, which I'm just starting up in the background. And so what I'm doing is I'm showing you this graph, and I have this basically described in the YAML file. The YAML file thing is entirely temporary because I don't have a DSL for my tool yet. That'll come. And what I'm going to do is I'm going to run this tool. I just want to actually make sure I have a new copy. So we'll just build a copy. It's written in Golang, which I love and hate for different reasons, but it's been an excellent fit for this tool. So what I'm going to do is I'm actually going to time this, make this a little bit bigger. Can you see that okay? Yeah? So I'm going to time it, and I'm going to use this graph definition, and I have this converge timeout. So after the graph has converged for 5 seconds, it's going to quit, okay? So that you see how long it took. And each of those exec types is going to take, is basically going to run sleep for 10 seconds. So if I show you graph8.yaml, so basically little exec types, sleep 10 seconds, very simple, doesn't do anything really useful other than for demonstration purposes. And so if we look at this graph, how long would this whole thing take if it runs in parallel? Scream it out loud. Don't be shy. 35 seconds. So that's right. So this whole thing on the left is going to take 10 plus 10 plus 10. Hopefully this one will run in parallel. Plus I asked it to sleep for 5 more seconds. So as long as we run in about 35 seconds, anything over that is overhead of the tool. So we're going to actually run this, and you'll see some stuff. So the tool starts up. It's kind of a bit messy debug output at the moment. It sees the graph, and immediately exec 1 and exec 4 both run. So they're actually both running right now. And then right here at the bottom you can see they both return. So they did actually run in parallel, and exec 2 has immediately started and is running right away. 10 seconds goes by, and exec 2, again with no output because it's just a sleep command, comes back, and exec 3 starts up right away. I'll just press some enter so you can see this running at the top of your screen. And basically exec 3 just finished running right there. And if you look, there you go. How long did it take? 35 seconds, basically, 0.017. So it really, really is a very, very low overhead tool. It's surprisingly efficient. And if you actually look at the timings, if you have 0.1 seconds here when it ended, about 10 seconds exactly later, the next thing ran. All right? Is anyone confused with this example? Because I'm happy to run it again. Don't be shy. Does everyone, who understands? Who is afraid of raising their hands at conferences? All right, excellent, good. So that's my first example for the parallel execution. This one, I'm really terrible at making these graphs, but this is basically the status quo in config management tools that run basically every 30 minutes or with cron, that sort of thing. You have a time, you look at the status. If something changes in the middle, you won't know until your 30-minute timer or your 5-minute timer or whatever is up and runs again. What I'm trying to actually build is that immediately the second you see something happen, you respond to it. So there's never that 30-minute window or 25-minute window or whatever long it is where you don't know what the state of your system is. Now, why is your system potentially going out of state in this window? Well, that's a more complex question, and we'll talk about it later. But I just want to show you how it works. So just to tell you what it actually does. So I have different types and resources that use different kernel mechanisms basically to look for events. So for file resources, I have inotify, in the future FA notify probably. For service events, I actually watch systemd dbus events. So it's a lovely thing that just tells you something has started, something has stopped, and so on. For actual exec, there's kernel events, and for etcd, you'll see there's network events. So let me just run this example. I'm just going to start this up. So in this particular example, so I have basically 4 different file types, F1, 2, and 3, and they each say, you know, I'm F1, I'm F2, I'm F3, and F4 is a file type that says do not exist, right? So if someone puts an F4 file, we're going to want to basically remove it. And just to make this, oops. So I'm just going to go over here. So the tool actually doesn't make directories yet, so I just have to make a directory for it. Patch is welcome. All right. And so on the left, oops. There we go. So I'm going to do the same sort of thing. I'm just going to, I don't need to really time this because it's just going to run. I'm going to run example 1, and I'm going to press enter, and boom. it's done already, right? Do you believe me? I'm going to go over here, ls, there's 3 files there. Cool? If we cat them all, you'll see that F1, F2, F3. Make that a little bit bigger. And you can actually just, remove F2, and if you see on the left, you have the tool running, which responded right away, and on the right you have F2. So, remove F2, boom, it's instantly right back. But it's actually much faster than. You can actually remove F2 and then cat F2, and it's back right away, right? And you can just go doing this, and every time I do this on the right, on the left you see the system says, hey, I know something's changed, why are you fucking with my system, and fixes it, all right? I'm just going to clear the screen. You can actually do even worse. You can actually just do watch-n 0.1, which is basically the fastest way you can run this, and just spin this guy along, and on the left, it's always there, right? So this thing, I hope there aren't any race conditions left. I think it's pretty solid, but you get the basic idea. Any random bugs we can definitely fix, but it seems to work. And obviously, if you touch F4, you want to play a joke on your sysadmins, like have them save their thesis document. And where's my thesis document? This is an evil thing to do. Don't do this. But if you touch F4 and file F4 just to see, you'll see F4 is never there, right? So that's basically just one example. I have an example with services, which actually has a small bug perhaps. So if I have time, I'll show you at the end. All right? That's events. Lastly, I want to talk about topologies. So this is basically your standard topology that everyone who has done some config management is familiar with. Yes? Yes? Come on. I'm trying to be energetic for you. I need some energy back here. Come on. All right. So you have some sort of server at the top, and you have a bunch of clients, and they go out and ask the server. This is a pain in the ass for some reasons because you got to set up the server. Why else is this a pain in the ass? Single point of failure. What else? Scaling. Anything else? Security, that's a hot topic. I'm not going to talk too much about security today, but it's something to talk about. This actually is a great topology, right? This is sort of the bread and butter of anything a sysadmin like myself has done forever, right? You set up servers and you manage stuff. Fortunately, in about, what was it, 1979 or something, this gentleman wrote an excellent algorithm called Paxos, and turned out it was so hard to understand that we had to basically find a simpler version called Raft. And now these algorithms allow us to do all sorts of amazing things. Anyone know who this was, by the way? Leslie Lamport, that's right. So this is the sort of one topology. This is kind of the Ansible topology. So as much as I love Ansible, Ansible is not configuration management. Please, if you don't ever use my tool, that's fine, but do stop calling it config management. It is a useful tool. It is idempotent. It does things that we commonly do with config management, but it is an orchestrator. And so I fundamentally see it this way. That's just a little gripe. But, this is the model, right? You have one thing. So whenever I say the word orchestrator, I'm talking about a central orchestrator. That's what orchestration means to me. It doesn't mean coordination. Some people are using the term choreography. I don't really know what that means either. But when I'm talking about orchestration, this is what I mean. You have a central orchestrator. It could be that your central orchestrator is transiently elected, but ultimately there's one thing that goes out and does things. All right? So that thing goes out and pokes machines. What are some problems with this? Yes? Scaling. What else? It's boring. Yes. That's a great answer. I might have to quote that person. Ping me on Twitter. Anything else? Slow. It could be slow. Someone said that too, so yeah. So here's one potential topology. So if everything is an agent and the cluster looks like this, here's just a six peers, and what do you notice here? It's a mess, right? There's a lot of interconnections, and if you scale this from like n equals 6 to n equals like 100, how many edges will you have? Too many, all right. We won't do the math. Someone's like, don't make me do the math. So this is actually not a very good solution for the tool, but fortunately there is actually a simpler solution, a little bit more complicated solution, pardon me, but it's actually quite elegant. So what you do is everything is still a peer. There's no special peers. Everyone's unique. Everyone is the same. However, you transiently promote certain peers to temporary masters, and that's what these M4, M1, M2, M3, M4 are. And then everything else connects to one of those masters. And this is basically what I'm doing with etcd, which is a fabulous piece of software, and we have some CoreOS people here. And I'm going to show you how this works. So, so here's the example. This might feel a little familiar to exported resources in Puppet, but done a little bit differently and basically running much, much faster. So I'm going to show you 3 nodes. Each of those nodes is going to create 2 files. Okay? What it's going to do is when this thing runs, when it compiles the graph, there are certain things in the DSL that will be able to say, I want to store this in the graph. I want to store this in a database, kind of like the export in Puppet. The other thing, so these are the 2 files it'll create. They're going to export to. The other thing it's going to do at compile time is it's going to look in this database. You can think sort of like PuppetDB in a way, and pull down anything that matches a certain pattern. So I'm going to export 2 files, and I'm going to pull down anything that's waiting for me. And it's basically going to be the same thing on each host, except A, B, and C will be different on each one. So let me just show you this. So I'm just doing this with one etcd at the moment. That's just running over here. And I'm going to kill this person. 3A. So over here, oops. Oh, wonder what that was. All right. Okay. Oops. So, oops. Oh, I forgot the slash. All right.
You had a lowercase c.
Oh, I did have a lowercase c. That's right. Thank you. All right, take 2. We have these directories. I'm just going to really blow everything away, make sure we're 100% clear. Oh my goodness. All right. All right, take 2. All right, so we have, and this is why we don't write config management in bash. We use a DSL that is safer. All right, so we have just these 3 directories. I'll just show you this example. This is really a crappy hack DSL. So you have 3 files, and 2 of them are getting exported. All right. So what I'm going to do is I'm going to run this agent on basically the first machine. It basically converges instantly. I didn't really measure that, but there we go. So if you see, there's actually the 4 files, right? So 2 are stored locally in this directory, machine A, if you will. 2 are stored in the distributed key value store, and they're pulled back onto themselves. So you have 4 files. All right. Now we're going to run the second agent. Okay. Basically the same thing. It basically runs instantly. How many files are we going to see when I run this? 8? 6, right? So if you look here, so this one, the first one, automatically responded and noticed that the database had changed, and it pulled back those 2 files from the second machine, and the second machine automatically pulled in the files from the first machine as well as itself. All right? And then lastly, graph 3C, this last one, just to show you how fast it runs, I'm going to run it, but I'm actually going to do this timeout thing. So after 5 seconds of them all going back and forth and communicating and exchanging and collecting and exporting, it'll end after 5 seconds. All right? So I'm going to run this, and we'll just run the tree right away. And you can see now you have your 8. And if you look, what's the time say? Can you see that? So 5 seconds, right? So basically the overhead of doing an export and a collect across 3 hosts is virtually minimal. Now obviously there's very little latency right here and things like that, but just to show you the overhead of the tool. And one of the reasons is because every time the graph runs, it only has to reapply the parts that haven't changed. So you don't have to wait for that long startup and check of every file resource and start over. Okay? You all are sort of blank stared, so I want to know if you have any questions so far. Yes, question?
Is it also then still watching those files? So
Yes, it is.
while it's doing, you delete one of them, it'll come back. And
Absolutely. So it's still watching those files and doing all of that. Yeah. It's completely...
Basically, it's also pretty much real time.
Yes, so yes, it is real time. Yes, it is watching those files. Those three concepts which I mentioned, the parallel, the event-driven, and the fact that it's distributed, all work together. Yes, person with the orange hat.
So I'm not very familiar with etcd.
Yes.
It's like you have now 3 of them listening.
Right, so what's happening is I don't want to write a raft-safe distributed key value store to store this in. So that's what I'm using etcd for. So whenever I push into a database, instead of having a central database like PuppetDB, I'm actually using this etcd database, which works really well. And the beauty of that is as I scale this cluster out into 3 or 4 or whatever, I'll always be able to replicate this database across wherever I need. There are actually some optimizations we can do to make this even better, but I don't want to talk about that today. I just want to keep it simple. Any other questions? Yes?
What are the dependencies so far? So it's etcd and
etcd, Golang, and I have a README that mentions the other things. It's very little. It's basically etcd, the Go FS Notify API, dbus API. They're very, very minimal. And because it's Golang, this all compiles into one single binary, so you can push it around. Yes, another question.
Do you plan to make etcd replaceable with other stuff like console or zookeeper?
Good question.
There are other frameworks
Yep.
that use Fluxus.
So the question is basically, why did I use etcd? Could you replace it with console or something else? Ultimately, there's actually an FAQ about this in the documentation. Surprise, I have like some documentation. Basically, it's ultimately arbitrary, and it was actually a really tough decision to pick etcd over console. This can be changed if we turn on. Oh, hello. That's okay. If we find that there's something wrong with etcd and we can't fix it, or if you really think you really need console over etcd, then we could probably change it. But it's basically arbitrary at this point. Let me just go on with a few more slides, and if there's more questions, I'm happy to answer them. So that's this example. Just some future work, because I want to show you I'm working on this, and there's a lot more. This is just the tip of the iceberg for me. I remembered in this lovely panel we had, people were talking about higher level resources and higher level types. Start thinking about what types you can actually write with this, if it's event driven. You could have a virtual machine resource type that sets up a virtual machine and changes it. You could have a container type that really dynamically works and sets things. You could have a whole bunch of things. I have some surprises that I don't want to spoil that will come sooner rather than later, but I just want you to start thinking about what sort of resources you can actually write, because I think that's going to be the value add. The file types, the service stuff, this is basic, this is ABC, but it will get more interesting. So there is some future work. So the most notably absent thing in the code so far, this is not a production-ready thing. Please don't use this on your servers already. If you do, please tell me about it, because that's going to be fun, but it's really, really just a hack right now. There's no DSL. So at some point there should be a DSL. Now, you could actually, and this might be just a side project that someone finds interesting. So if you have all this Puppet code, you could actually take your Puppet code, I believe, and write a cross-compiler that takes Puppet code and makes it run on my engine. It would probably run way, way faster, and it might run, you'd have to make sure you have all the dependencies properly mapped, but you could do this sort of thing if you wanted. I'm not working on this. I do have plans to actually write a DSL, but I don't have all of the designs ready. Some of the primitives I have designed, so this is really an open discussion. It'll most likely be declarative. I was looking at FRPs, functional reactive programming, if you want to look into that. I don't have the answers, but if you are a language expert, I'm not, and I don't want to I don't want to mess up the language. So if you really are a specialist in this area, please let me know. So there's going to be some obviously new resources or types. Package actually isn't implemented yet, but I'm planning on doing it entirely on top of PackageKit, which does provide events. I'm going to probably implement timers so you can do some fun things, and exec needs a lot of extensions too. etcd, I'm in the process of embedding it into this binary so that you can start up and stop the server dynamically, and a few other things. So if you're an etcd core contributor or etcd pro, please let me know. I'd love for you to help out with this. Who is laughing? Is it the community part? Oh, well, maybe I missed the joke. What? The name of my tool. Oh, I didn't mention this. The name of my tool is Mgmt. I'm really sorry. Yeah, so I'm really bad about naming things, so you'll have to forgive me for that.
That's Chris' trademark.
That's what?
That's Chris' trademark.
Well, I'm going to pay off Chris, so no problem. So yeah, just to go back to here, where did I go at the end? So I work for Red Hat. Red Hat's been actually surprisingly nice, and a lot of people have supported my work. But I'm basically working on this alone at the moment until sort of they see that it's really catching on or whatever. So the beauty is I'm actually running this as a completely upstream project. So if you want to contribute, if you want to be a company that does support for this, if you want to send patches, this is our tool, right? And it's going to stay that way. So please, if you want to get involved, this is what's going to drive it. I want to hear your thoughts. Just really quickly, how can you help? You can use this, you can test it, you can patch it. I have a pretty advanced testing framework which is almost entirely built out, which I probably blog about when I can. You can share this, you can document this. If you want to give me GitHub points, please do this, because I think hopefully there's a bit of a bandwagon effect that hopefully helps projects. You can blog about this, you can tweet this. I'm Purple Idea, so tell all your cool friends. I got some great support on the internet recently. A gentleman from IBM named Spencer, who is somewhere. Where's Spencer? Oh, he's not here? Oh, he's hiding, he's shy. But he encouraged me to actually blog about this before the conference, because I was originally planning to release this here. And just hack on this, right? This is code for everyone. It's completely open source. This is my one marketing slide, because Red Hat pays a lot of money to send me here. I'm from Canada, so I had to take a plane and train and all this stuff. So totally upstream project, totally about community. We have an IRC channel, Mgmt config on Freenode. So if you want to lurk with us, come lurk. I sometimes post little, hey, this is what I'm doing, messages if you want to follow more quickly. This is a project, not a product. Okay? This is not something you can buy from Red Hat. This is just an upstream project. If Red Hat productizes it, that will be a decision they'll have to make when they get there. So right now, just a project. And let's just recap.
Yes. Now let me recap.
Have you seen this guy? He recaps his pen. He does this Mathemagic talk. It's great. So technical blog of James, easy to find out. On GitHub, MGMT. I'm really sorry about the name. I stress about my variable names and my project names for months, and I couldn't think of anything. I asked everyone, and this is the best thing I came up with. So I'm sorry. It's short. It's relatively descriptive. I think it's stuck for now. I'm sorry. I have the one blog post about this if you want to check it out. And I'm basically Purple Idea on most of the internets. I'm actually giving one more talk about this at DevConf in Brno on February 6th, which is very soon. It might be recorded, I don't know, but if you can come, it's a really great city, it's very inexpensive. I'm happy to take more questions until Chris kicks me out, because I don't want to stop you guys from beer, and that would be mean of me. So how long do we have for questions?
1 minute.
The beer is flowing.
The beer is flowing. So how about a few questions, and we'll go for some beer. Any questions? Yes.
What is the reason to build it?
The reason to build it is because there's a lot of stuff that I want to build in config management and automate that I really didn't think the current state of tools can do. I don't think they're up to the task. You can still do a lot of great things with these tools, but if you want a dynamic thing, if you want a very powerful thing, I didn't think any of the existing code bases could be saved in that respect, and I did seriously look. So eventually a lot of people said, just write the thing you want, and that's what this is. So any other questions? Yes, Felix.
That was a cool demo. I think I missed the part where you went into how you handle things that don't paralyze.
How do I handle things that don't paralyze is his question. Some things don't paralyze. If you have an explicit dependency that says this thing must happen before that thing, then they just run one after another. You can't get around that. I mean, if you want something to happen in a certain order, we won't break that if you don't want it to.
What if you have two different trees?
Yeah.
And they are running a package install, for instance.
Right, so the question is basically about package locks and how you do that. If you have something like a package lock, you can't paralyze those things. There is something that I have not talked about because the code is not merged at all, but it is actually relatively easy to group certain things that can be lumped into one transaction. So for packages that are not dependently or explicitly required that should happen in a certain order, the graph will actually mutate and group certain things together. So you can think of doing packages this way. So if you have 3 yum installs that basically have to happen, it will group those together into one transaction. Other things too, like for example, if you had a free IPA user type and you had 1,000 random, user add, user add, user add, you can actually write a type that wraps this and does a more efficient API call to a server instead of basically running each type individually. So there will be grouping, but that's the subject of a later blog post. Yes, question?
About packaging, that I thought you told that you may be using package kit to do the packaging first.
Yeah.
And as far as I know, if you use package kit, it will already do the queuing of the different jobs for you, so you can add new transactions to the queue.
Right. So the question is basically, if you use package kit, doesn't it automatically do this for you? It does actually queue things up if you want it to, but behind the scenes it will still run a complete yum transaction followed by a second complete yum transaction. So yes, you could do a naive implementation that doesn't think about this, but in practice we will actually group the types themselves. Any other questions? More questions? How about the gentleman in the back?
You proclaimed the purpose of Ansible. So how are you going to do remote tests, for example?
How am I going to do remote tests?
For example, if I want to configure a remote system.
Right, so it's a great question. This is something I also didn't want to talk about. I don't want to, I'll actually answer your question because you deserve an answer. I want to be as open as possible. Until I'm the only, I don't want to talk about things that I haven't implemented yet too much because it's just basically giving Oracle a chance to rip off my ideas. But, or, it's, I want to talk about code once I know that it works and the design is correct. But if you want to do the Ansible model, it looks entirely possible. So basically the general thing would be if you want to not have anything on the machine, you run Mgmt on, say, your laptop, it SSHs in, copies that one binary, which is part of the reason why I'm choosing Golang, because it's trivially easy to do this, runs that, channeling the etcd connection traffic back to that laptop, and then just runs, and if you want, it can converge and exit, basically when it's done. This will actually be, I think, more powerful in Ansible because the different hosts that you're running this thing on can go back and forth and wait till they all converge and then you exit. Whereas with Ansible, you'd have to do multiple runs if you haven't pre-looped that. So it's a little bit of a complicated thing, but it's actually something that should be relatively easy to implement. And if you want to work on this, I will show you where to add it. Yes, orange hat person.
Can you tell us something about your license choice?
The question is about licensing. This is not a legal talk. It's free software. It's GPL. I don't really want to talk about licensing. It's not fun. But basically, it doesn't really matter because when you're running it, well, hang on. I wanted to pick some copyleft because it's my guarantee that me or Red Hat or anyone else is never going to screw you over and never go open core. Okay? And that's the key for me. I'm never going to do Apache for the core or MIT for the core because that would give me or Red Hat the ability to proprietize part of it, and I'm totally against the open core model. So there will be copyleft in there. For the standard lib, it'll most likely be LGPL 3+, because I want you to link for whatever. But in practice, it turns out if you run, and maybe not everyone knows this about licensing, but if you run this on your servers, you can basically do whatever you want. Even if it's AGPL, you don't have to release any proprietary stuff that you run on your stuff. And config management is unique in that sense. So if you have more questions, let me know, we'll talk after. But this shouldn't stop you from doing anything proprietary on your own kit. Any more questions? Don't let me, yeah, David.
What are your thoughts around simulating changes? Like, you've got something out there,
Yeah.
And then you change your graph, and now before I go live with the graph,
Yep.
especially with the export collect type stuff.
That's a great question. David's question is, how do you simulate this? Like, can you do a Noop sort of thing, kind of like Puppet, basically? There's two parts to this answer. So it's not implemented at all, but you will be able to do, when I get the time to code it, a simple Noop, a simplistic Noop that basically just looks at one element or one host and sees what it would probably do. That's basically equivalent to what Puppet can do. As for multi-machine Noops, that's something that's not really even possible in Puppet. And it won't be trivial to simulate this kind of thing. The brief amount of research that I've done into this is that if I pick the right DSL, there is a lot of graph formalism that you can use to actually analyze a system statically and have a good idea of what will happen and if your system will ultimately cause a loop and these sorts of things. So this is going to definitely require the help of a computer science person to really get this right. I do think it's possible, and if you know someone that wants to work on this, please talk to me. There was one more question. Is that a good answer for you? Yeah. One more question. Danny?
Yeah, so you mentioned that with Puppet you could pretty easily cross-compile it because it actually has a graph. So
Yep.
what about the other tools?
Absolutely. So with Puppet I'm most familiar with. I'm really looking forward that the Puppet community is interested in this and hopefully, wants to step up and help do this work. I think it will really give their, existing code bases a new lease on life. So you can have all your existing Puppet code running normally, but for the really hard things to do in Puppet that are really multi-machine, you could write that new part only in the new tool. As for Chef and Ansible, Ansible is a longer conversation on how we would do this. I think for Chef it's similar to the Puppet case, and so I'm hoping that if they're interested that they will participate as well. I really don't know the Chef internals as well, so it's really, if Chef people want to talk, please let me know. And every other community that I haven't talked about, please, I'm really happy to hack on this with you. Any other questions? All right, I think it's time for beverages. So thank you very much for listening. I'm Purple ID on the internet. Thank you.